Mr. Freitas traveled along the Pali Highway uphill and through the tunnel at 30 miles per hour for 6 miles. He then went downhill at 50 miles per hour for another 3 miles over that Pali Highway. But what was his average speed for the whole trip over the Pali? At the very end of his trip on the Pali, at the bottom of the hill, he went through the speed limit. It said 35. And then he got pulled over for speeding. Whoop whoop, whoop whoop, whoop whoop, pull over, pull over.
You're in trouble. You were speeding.
Oh no, I'm sorry, officer.
I'm gonna tag you for everything.
No, it's okay. You don't have to give me a ticket. What if I gave you a donut?
Ooh, donut! Wait, don't try to distract me.
Come on, give me a break.
Now I'm going to get my police dog.
Cute.
Take me seriously.
Aw, still cute.
I'm gonna tag you for everything.
Let me explain, Ossifer. You see, you're getting me for my instantaneous velocity. But when you take my whole trip into account, my total distance and time, it's average velocity. Plus, the sign didn't have units on it. It's got no units. Oh my gosh, guys, that's like so true. Look, it just said speed limit 35. What is it? 35 what? 35 kilometers per second? No ways I went 35 kilometers in 1 second. What is it? 35, what is it? 35 monkeys? What? I don't even know what that means. There's no units. It doesn't have a meaning without units. Okay? It just says 35. Oh, it's probably in the driver's manual. It tells you what that's supposed to be. I guess I should have read that. Well, maybe we'll work on my other excuse, where you have to think about the average speed instead of the instantaneous speed. Yeah, maybe we'll get away. Let's try that. Hello, everyone. So here is that problem once again, and we got our little video earlier. It was kind of humorous telling the story. Okay, what we're going to do is we're going to try and solve this problem now, and I'm going to do that on pen and paper because I'm not super cool with my iPad situation. But it's going to be a problem where we're talking about average velocity, not just the instantaneous velocity. Even though the average velocity probably won't get us out of trouble with the police officer. Okay. Now I'm going to take my time with it because it's a video. You can fast forward it if you don't like how long it's taking me to set things up. But we have some givens in here, and so you can rewind to look at this problem, but I'm going to be writing this out on your folder paper in a second. And we're going to solve this. We're going to solve for average velocity, and we're going to look at that basically distance equals rate times time, or velocity is distance over time. But we have kind of two different values for velocity going up and downhill, and we have different distances in time as well. And I'll show you some problem solving steps for that. So when we look at our givens, guys, we've got going up and going down. So sometimes in your givens, ladies and gentlemen, it's important to draw a picture. It's not required in our regular physics course to draw a picture, but sometimes it's helpful. And later on, when we get into talking about forces, it's definitely going to be part of the givens that we're going to require. If we don't see a picture, then it's a big no-no, and you might lose some points. Okay. So looking back at the problem, some of the givens that you would have read there, and you can rewind for that, is that we're going up along the Pali, and we travel at 30 miles per hour for 6 miles. So everything that was in that paragraph, I'm reading off the paragraph, and then I'm writing it as givens. So 6.0 miles going up, and that was a velocity that we had going up, our car's going up, chug, 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 chug. And I'm gonna call that velocity 1. See if that's looking pretty clear. Yeah. That's going to be velocity 1, and that's going to be, and I keep having to read my paragraph, 30 miles per hour. Okay, and 50 miles per hour down, so it's going to be faster going down. And then it's going to be speeding faster going downhill, right? And that's probably where we got like our speed limit sign, 35, whoop, whoop, and our instantaneous speed was maybe 50, and we got in trouble. Oh no. So 50 miles per hour heading downhill, but it wasn't my average velocity for the whole trip. And so I try to tell my little story that's not going to get me out of trouble. But the fact that, hey, I was going slow on the way up, at least, give me credit for that. You probably won't. Okay. And so what we're doing here is we're finding our average velocity, which is my total distance over my total time. And actually, I do have my total distance because my total distance is 6 miles up and 6 miles down. So I could say that's D1 plus D2, and T is my total time. But that's 6 plus 3, so I can take a little bit of skipping my steps there. But the bottom one is T1 plus T2. So this problem might be more advanced than some of the things we'll be doing, but it's definitely problem solving, so it's an interesting example to look at. In general, distance is equal to velocity times time, which is the same idea as velocity is distance over time. But we can rearrange this. There's like 2 ways. There's a third way to rearrange this. You could say that time is essentially distance over velocity. Okay? And generally, I could do T1 is D1 over V1. And I could do another version where T2 is D2 over V2. Okay? So my distance going up could be 6 miles. And that corresponds, that's why it's good to have our givens written down. Over 30.0 miles per hour. You can calculate that. Let's plug in the second part correctly. So it's a matter of taking your time and doing your bookkeeping. So 3 miles for D2, that's what it says, and 50 miles per hour for V2. So, you know, patience is a virtue. If you have the patience to do things right, things will work out. So you use your calculator here. My calculator. Okay, so calculator. 6 divided by 30. That's not necessarily showing up too great, but there we go. So 0.2, and maybe sig figs, yeah. 2 sig figs at least. But this would actually come out to hours, because you're dividing by something that's in the denominator. The miles cancel. Then we've got 3 divided by 50. Yeah, that won't take as much time because I'm going fast over a short distance, right? Fast over a short distance takes less time. Now I've got my 2 times and I'm almost done, guys. Yeah, because we're solving for average velocity. It's total distance over total time, which is 9 miles. My total time is T1 plus T2, so that's 0.20 plus 0.06. Those are both hours. So it might look a little small. I could blow it up, but then I run the risk of it going a little wonky. So that's 9 miles over 0.26 hours. Which gives you an average velocity of about 34.6 miles per hour, which is about, guys, if we're around that, 35 miles per hour. So my average velocity for my whole trip was 35 miles per hour. Doesn't that count for something? Probably not, because the speed limit, if you're breaking it at a certain instant, you still get a ticket. But just for fun, we calculated our average velocity for going all the way up and all the way down.